Okay, so today we're talking about complex numbers, which are also called imaginary numbers. If it is a pure imaginary, you only have one term. Okay, if it is a complex, it has a real number to it as well. And the form we call A plus BI, okay, where your A value is real and then the B value is imaginary. Okay, so let's just write down an example of each because I know you've never seen these before, so it's probably a little confusing. Okay, so an example of just a pure imaginary number would be something like 3i. Okay, and if you had a complex number, 2 plus 3i would be an example of that. Okay, so we're going to be working with radicals today, and we're going to be doing this without a calculator. So imaginary numbers, we're going to define them. So the definition, it is the square root of a negative number represented by I. Okay, so I for imaginary. The square root of a negative number represented by I. Oh, yeah, so it is, whenever you do the variables, it is the italic version. So yeah, I will make it like that, and that's how you'll see it in the book as well. So the imaginary is equal to the square root of negative 1. Okay, so I is equivalent to the square root of negative 1. And from there, we can derive I squared. Okay, so if I is the square root of negative 1, to get I squared, you can just take the square root of negative 1 and square it. Do you guys know what a square does to a square root? Yeah, it cancels it out. So when you undo that, that means I squared is equal to negative 1. Okay, and we're going to box this in because this is the value that we're going to use the most. Okay, now we can also extend that to other variables or other powers of I. So if you had I to the third power, okay, think of your properties of exponents. Okay, if you have I to the third, you can rewrite that as I squared times I. I squared times I would give you I cubed. Okay, the reason why we want to think of it like that is because now that we know that I squared is negative 1, we can substitute that in. Okay, so you could write it as negative 1i, or you could just write it as negative I. Okay, so I cubed is equal to negative I. Okay, that's another one of your properties. Should I let you guys try I to the fourth? Think you could rewrite that one? I to the fourth? And there are a couple ways you can think about it. You can think of it as I cubed times I. You could also just think of it as I squared times I squared. Okay, because you know that I squared is negative 1. So if you multiply negative 1 by negative 1, that's going to give you what? 1. Okay, so I to the fourth is equal to positive 1. Okay, so you're going to end up finding different values. Okay, you can use these fractions. Usually we will try to write everything in terms of I squared, okay, because that is -1. Okay, whenever you are simplifying radicals, like we did for our warm-up, you never want to have any perfect squares under the radicals. So when it says simplify, that means there's no perfect squares under the radical. Okay, and then let's list out the perfect squares. Just list them out here. So to find the perfect squares, you just square the numbers. We'll go up through 10. So 1 squared is 1, 2 squared, 4, 3 squared, 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, okay, so on and so forth. Okay, so perfect squares are any number raised to the second power. So that's what we're going to look for when we are simplifying. Okay, we are also going to use this rule that if you have two values multiplied together, this only works with multiplication. Okay, you can't do this with addition. Okay, you can write this as root A times root B. Okay, if A is greater than or equal to 0 or B is greater than or equal to 0. You can't use if both are negative. So one of those has to be a positive value. Okay, if both are negative, you cannot use that because it would get rid of the imaginary part. Okay, so for part A, we're going to simplify the square root of -16. Okay, so if you just had the square root of 16, we would know that that is 4. Okay, when you are simplifying this, it's the same thing as the square root of -1 times the square root of 16. So what we talked about just a moment ago is that the square root of -1 is I. We know that this is a perfect square of 4. So our final answer here, we're going to write it as 4i. I will always go behind the whole number, just like when you have 2x, right? You don't write x2. Okay, so always going to be in front of that variable. All right, and then the next one is the square root of -96. Okay, so there's a few different ways that you can do this. Okay, the first thing I would do, whenever you see a negative, we know that it's going to make an I, so you don't have to like write out this stuff every time. You can just make this I square root of 96. Okay, and I'm going to show you how to factor tree. So these are perfect squares because they come from a number to the second power. 4 is 2 2s, 9 is 2 3s, 16 is 2 4s. Okay, so when you do your factor tree, if you can find a group of 2, if ever you have a group of 2, one of those values is going to come out. Okay, so for 96, if I cut it in half, that's something easy I can do without a calculator. Half a 90, half a 6, add them together, 48. Okay, and you can keep just going by 2. If you'd rather do like a 6 and 8, you could do that. This would be 2 and 3. You just keep going until all your factors are prime. So this would be times 4, this would be 2 times 2. Oh, thanks. Okay, so if there's a group of 2, you can bring those out. So you have 2 and 2, so a 2 is going to come out. You only have 1, 3 here. There's no other place to put that, so we're going to keep it in the radical. Here's another group of 2 2's, so that comes out and you multiply it. And so 3 doesn't have a partner and this 2 doesn't have a partner, so those go inside. And so we can write our final answer is 4 root 6. Okay, you can also use, and then you have to put the I with it. So I'm going to put the I in there so I don't have to write it again. Okay, so you have the 4i times root 6. You can also find a perfect square that goes into this. So you can also do I times, you can rewrite this as 16 times 6. Okay, and that would be 4i root 6 as well. That's another way that you can simplify it. Okay, so you can choose whether you want to use pairs, okay, in order to come out. One more thing I just want to say about this, in case you guys are struggling with the simplifying, is the reason why these come out is because what's 2 times 2? 4. So this is like root 4 times root 3 times root 4 times root 2. So the 4 simplifies to a 2. This can't simplify. This simplifies to a 2. This can't simplify. So then you just multiply these together. Okay, that's where that comes from. You're taking the square root of 4 to get the 2. Okay? All right, so I'm going to have you guys try part C. Again, there's more than one way to get to the correct answer. So I want you to try this. So those are both a negative, so we can't just multiply it and make it positive. Okay, so let's start by taking out the I values. So you have I root 24 multiplied by I root 2. Okay, and then go ahead and simplify the square root, or get that up. Okay, so once you have the i's taken care of, okay, then you can multiply the radicals together because they're both positive. So you could make this the square root of 48 and then simplify. And then I times I is going to be I squared. That goes out in front. Okay, and then again, if you want, you can do the factor tree. I'm going to show you how to do that again. So I like to divide by 2 for as long as I can, just because if I do this all over the place, sometimes I'll miss something. Okay, so now I have all my prime numbers in a row here. Okay, so if there's a group of 2, it comes out. If there's a group of 2, it comes out. So 2 times 2 is going to be 4, and then you'll have the root 3. Okay, so this is I squared times 4 times root 3. Whenever you have I squared, you can replace that with -1. So your final answer is -4 root 3. Okay, you don't have I in your answer because we were able to substitute that negative. Okay, you can also, for this one, if you like, some of you might have known the perfect square in 48 is 16. Okay, so again, this would be -1, this would be 4, this would be √3, and then you multiply those together. Okay, so whatever one of those is easier for you. It depends on how comfortable you are with multiplication facts. All right, any questions for me on ABC, on the simplifying there? Because the next thing we're going to simplify are terms with I. Okay, so for D, we're going to have I to the 32nd power. Okay, whenever you have an I term, okay, your goal is to rewrite in terms of I squared. Okay, and I'm going to help you with that. So we're going to rewrite in terms of I squared. Okay, and we're going to use our power rule. So when you have a power to a power, you're going to multiply. So if you take 32 and divide by 2, what do you get? 16. So I can write this as I squared to the 16th power, because 2 times 16 is 32. And that's helpful because then I'm just going to plug in a -1. Okay, and if you do -1 to the 16th, is that going to be negative or positive? Positive. Any negative number that is multiplied an even number of times becomes positive. Okay, so your answer for that is just going to be 1. Okay, and then if you wanted to, you could write this in terms of I to the 4th. Okay, there are other options to get to the same answer. I just found it's easier for students to remember like one way to always do it. All right, and then we're going to simplify this for E. So you have numbers and you have variables. All we're going to do is multiply the numbers together, multiply the variables together, and then we're going to simplify from there. So if I multiply the numbers, okay, I would do -6 times -5, because what's that? 30. 30 times 2, 60. And then how many i's do you have? 3. So I to the 3rd. Okay, great. And then again, you are just going to write this in terms of I squared. Okay, or if you can remember that I cubed is -I, you could absolutely use that. Okay, so if you think of this as 60 times I squared times I, again, you're just plugging in that -1. I like to show you this way in case you don't have I cubed memorized. I want you to know you can still get to the right answer. Okay, just by knowing I squared is -1. Okay, so you do have to know I squared is -1. The rest can be derived from that. All right. I'm going to have you guys try this, but I am going to tell you to remember your order of operations. Okay, what are your order of operations? And let's give it a go. so order of operations, you have to do exponents. So what's negative 7i squared? 49i squared. Okay, so just keep in mind this is negative 7i times negative 7i. It's like that. Okay, so negative 4i times 49i squared. Okay, and we're going to do 49 times 4. You could also just do 50 times 4. What's 50 times 4? 200, and then you can just subtract 4 from it because it's 1 away. Okay, or you could write it out, whatever you're comfortable with. Okay, so this is negative 196. I times I squared is I to the third. Okay, and again, when you're doing this, I know you can see I cubed is negative I. You can absolutely plug that in. I just want you to know, like if you're doing this on a test or a quiz, you don't have to have I cubed memorized. As long as you know I squared is negative 1, you can always get to the correct answer. So a negative times a negative is a positive, so this will be 196i. Okay, one thing we're going to work on a lot this year is being fluent with radicals without our calculator. All right, and then in example 3, we're going to solve each equation. When you are solving for x and you take a square root, you are going to need a plus or minus when solving with the square root. Okay, so that is something small that sometimes people forget, but you do need it for your complete answer. So if you have 2x squared plus 288 equals 0, geez, some of you feel like you can do that without me? Okay, let's try to do. So you're trying to get x by itself. So let's isolate the x variable. Okay, so your first step, you are going to subtract that over. Okay, so I do need to see your steps here. I'm okay if you do that. Just again, make sure when you move it over, you don't forget to do the opposite. So you get negative 144. When you take the square root, you need the plus or minus in front. And then to get out the negative, it's I. And 144, is that a perfect square? Yeah, what's the square root of 144? 12. So this is just going to be 12i. Anytime you have a negative inside the radical, okay, you will have an I in your answer. Okay, so this is like I times the square root of 144. You know, that's going to be 12. And then again, do not forget that plus or minus.
When are we going to have?
Whenever you're solving. Because you don't, if it's x squared, right, there are two things that would make 144. You could have 12 squared or you could have negative 12 squared. So we don't know which one it is because both of those are going to get that same value. So you should isolate before you take the square root. If you don't, you would end up with 2x squared, and this would be root 2 times the square root of x squared. So you could write this as this, and then you have to deal with that. So you can still get there. So we have 3x squared. When we move that over, it would be a negative. Okay, remember that you can see right away whether 3 goes into something by adding the digits. 1 plus 5 plus 0 is 6. 3 goes into 6, so it'll go into 150. Okay, so if you divide that by 3, you get negative 50. Again, when you take the square root, you have to keep in mind that you're going to have a plus or minus. Okay, so x is going to be plus or minus I root 50. Because of the negative, I'm going to bring the I out. And then 50 isn't a perfect square, but there is a perfect square inside 50. And do we know what that is? Yes. And so I think it's a lot quicker when you know that perfect square to just simplify like this. Okay, so your final answer would be plus or minus 5I root 2. All right. And then when you are simplifying, your form is going to be A plus BI. That's how you're going to write your answers. Okay, and then this was just simplify. Okay, you are going to be adding your like terms together. All right, let's do this. All right, so for A, we have 4 plus 2I plus negative 6 minus 7I. Okay, and all we have to do here is add or subtract like terms. Okay, so you really treat the I in this case like you would an X, like any other variable. So if you have 4 plus a negative 6, you would get negative 2. Okay, and then 2I minus 7I would be negative 5I. Okay, and then this is in the form A plus BI. The real number goes first, the imaginary term goes second. Okay, now when you do the subtraction, why don't you give that a try? See if you can do the subtraction. Okay, so when you're adding or subtracting, you are just combining the like terms. I find it helpful for me to distribute right away. So I make this a plus 2 and a minus 3I, and then I just combine them. So this is going to be 3, and then negative 3I minus 3I is negative 6I. Okay, so then this is going to be your final answer. So it's common sometimes when you have that negative, sometimes people forget to distribute that. Okay, so that's going to be something we're going to look at. Okay, all right. And then, so this was addition and subtraction. We're also going to do multiplication today. Okay, so for part C, we have 3 plus 6I. Thanks. And then 4 minus I. And those are multiplied together. Okay, so this is where we have to do FOIL. Or I think that I told you guys last week I like to do FEAL, right? I like to do the inside first. So first times first just means you're multiplying 3 times 4, so you get 12. Okay, I like to do the inside here, which is 6 times 4, 6I times 4, so it's 24I. Okay, and then here I have 3 times a negative I. So 3 times a negative is negative 3, and the I is going to go with it. I like to put these here because then I combine my like terms right away. Okay, you don't have to do it exactly like that. I'm just showing you what works for me. Okay, and then here we have 6I times a negative I. So 6 times a negative is negative 6. I times I is going to be I squared. Whenever you are working with I squared, you are going to substitute. So we're going to write a little note up here that you are going to substitute negative 1 for I squared. Whenever you have an I squared, you're not going to leave it like that. You're going to substitute in the negative 1. Okay, so think about what's happening there. If you plug in negative 1, this is negative 1 times negative 6, so that becomes a plus 6. So we have some like terms we can combine. We have 12 plus 6, which is going to give us 18. And then the 21I, there's nothing to combine that with. So we are going to keep our final answer like this. Okay, so based on that, why don't you guys give this one a try? Okay, and I do need to see your work for this. Okay, I do need to see what you get when you multiply. Okay, so 2 times 2, we should have got 4. And then here we had 18I. On the outside, we had negative 18I. So those canceled out, right? 18I minus 18I is 0. Okay, and then 9I times negative 9I is negative 81I squared. Okay, how did we do getting here? 4 minus 81I squared. Okay, if you have the plus 18I minus 18I written out, that's great. Okay, so now we know that that's going to make 0. For I squared, we're going to plug in negative 1. So if you have a negative times a negative, it becomes positive. And then 81 plus 84 is 85. Okay, so in this case, the middle terms cancel. That happens sometimes. Okay, and then you get 85. All right, now this application is going to go with something we just talked about. So it says the voltage V of an AC circuit can be found using the formula V is equal to CI. Okay, where C is the current, I is the impedance. I have to look up how to say that. So if C is 3 plus 2J amps, and I is 7 minus 5J ohms, determine the voltage. So let's use our equation. Our equation, V equals C times I, and they give us an expression for each of those. So all we have to do is substitute, right? This is your value for C, 3 plus 2J. Your value for I, 7 minus 5J. Okay, so we're going to FOIL that, and then in electricity, J is equal to I. Okay, so if you have j squared, we're going to plug in -1 for that. Okay, so I want you to go ahead and multiply those together. Okay, so hopefully we're feeling really comfortable with FOIL. 3 times 7, 21. And I know I've been writing them out like this. If you guys want to write out everything in a line, of course you can do that. And then you can combine your like terms. Okay, so keep in mind you are going to plug in the -1 here. So show that step. So you have 21 minus j plus 10. So your final answer is going to be 31 minus j. And that's going to be in volts. Determine the voltage. All right, and then we're gonna save the last example for tomorrow. Your homework tonight is due tomorrow, so it's just gonna cover up through example 6.